Alright, welcome to the Learning Target number 2 video. We've already completed the Learning Target number 1 video in class, so you've already learned how to solve one-step algebraic equations using inverse operations, which you know all what that means. So that's going to lead to what we're doing here today. So this is very, very similar. So a lot of this we've already done on review sheets, so this should be review. So go ahead and we're going to go ahead and take care of Learning Target 2. Go ahead and flip in your notes to page, let's see here, it looks like page number, I don't even know, 4 maybe. Don't mind all the crazy stuff going on here. Just get rid of that. Okay. I don't know why it does that. It has done it all year. It's crazy. Okay. Alright. These symbols, again, we're going to do Learning Target 2 and 3 together, so we'll hit both those at one time, so that's why they're combined there. These symbols just mean, this one would mean greater than or equal to, so greater, and that's what it says on your paper, I think, or not I think, I know it does, greater than or equal to. That's just, it's a greater than symbol. With the little line underneath, this would be less than or equal to. So less than or equal to. Okay, and then I'm assuming, hopefully I don't got these backwards, I'm assuming that's greater, just greater than. That's the one you guys are more familiar with. And then this one here would be just less than. Now, there are some of you that are still struggling a little bit with remembering which one's which when it comes to these inequality symbols. Now remember, the inequality symbol means not equal, okay? Now we know that these ones here, the newer ones that you guys aren't used to seeing, they can be equal to, but they're still called inequality symbols, okay? Show you what I mean by that. Alright, the way to remember the greater than or less than, the way I've always been taught, first of all, the little, I mean, I think I did this earlier in the year, but it's kind of like a little monster thing. I know, that's just beautiful. He looks happy. But it's always wanting to eat the larger number. So that's one way to remember it, that students remember in like this. You know, it's trying to eat the 7 because 7 is larger than 6. You could remember it that way, but I don't really like that method only because I want you guys to remember what they are. When I put a symbol up there, I want you to remember that as less than. I want you to remember that that is greater than or equal to. Okay, and I expect you to say those terms. Okay, not it's trying to eat the bigger one. You guys are in 6th grade now. It's time to start calling them what they are. Okay, so when I look at the greater than or equal to, the way I remember it is I look at it and I say, okay, we read left to right. Everything we do is left to right now. Okay, think about PEMDAS. You do multiplication or division left to right, adding or subtracting left to right. We kind of do everything left to right. So I think that's the best way to remember it. When I put those two signs up here, I realize that when I look at this inequality symbol, I see the greater part first. So when I see the greater part first, I know that this is greater than. Okay, over here I see the less than part first, and that would mean that this is a less than symbol. Now the other way that a lot of maybe your elementary teachers taught you, which this is fine, is they just remember that the less than looks like an L. I mean, that's probably the easiest way to remember it, is just if you can remember that the one looks like an L is less than, then you're good. Okay, like I said earlier, the only thing different than what you guys have learned in the past is now we're going to be dealing with this or equal to on there. Okay, which means that you could also include that number, whatever it is. Okay, for instance, 6 is greater than or equal to 6, but 6 is not greater than 6. That's not true. But 6 is greater than or equal to because you have to add that equal to on there. Okay, so let's read through these questions here. And mine didn't copy all too well, so just bear with me. A bag of tomatoes weighs more than 5 pounds. Find the possible weights of the bag of tomatoes. Now, if it weighs more than 5 pounds, we're going to let a variable represent the, how much the bag actually weighs. Okay, we don't know how much it weighs, but all we know is that it weighs more than 5 pounds. So this would be a greater than symbol, because these values right here, these solutions we call them, everybody write that, solutions, they're just answers that could fit in here. are all going to be greater than 5. So you can look and see what they got down here. There are many, many, many that you can put in for x and make it true. Okay, 5.1, 5.2, 5.3, 6, 100, 5 million, 10 million, a billion. Any of those would work. Okay, now these aren't the only ones. I mean, this could go on forever. 5.1, 5.01, 5.001, and you could do that forever. Or you could do 5.11, 5.12135. I mean, think about all the possibilities that this could be. So that's why we use this word right here, infinite. Infinite. I think that's how you spell it. I hope. Okay, it just means that there are more than you can count. There are more answers here than that you can even account for. So when we put x greater than 5, we are saying all the infinite solutions that would make this a true statement. And like I said, there are infinite amount of those solutions, okay? And it's all because the bag of tomatoes weighs more than 5 pounds. It can't weigh exactly 5 pounds, but as long as it weighs more than 5 pounds, it's somewhere in that range. The bag of tomatoes weighs somewhere between 5 point something, whether it's 0.0001 and infinity. It can weigh billions and trillions of pounds in theory, okay? So that's that. Okay, now, as far as the number line goes, now you're also going to graph these on a number line, okay? Now I want to make a couple of notes here that you guys got to pay attention to. There's kind of a lot to this. Okay, we're going to graph the inequality x greater than 5, and a lot of you saw this on review sheet 25, so a lot of you got it figured out and you thought it was easy. So this is the same deal. Okay, we're saying x is just, again, the actual weight of the bag of tomatoes. We don't know how much it is, we just know it's bigger than 5. So we are going to put a dot on 5. Now notice, that is an open dot. Everybody write that. Open dot. Needs to be written because that's important. Here in a minute you'll see why. It's an open dot. And then we're going to shade one way or the other. It's either going to be shading this way or this way. Now they showed their shading with just a line, which is fine. That's how I do it as well. Okay? And they're basically saying, where are the solutions for x here? Where are the solutions? Are they this way or are they this way? Well, we're talking about solutions that have to be bigger than 5. Therefore, we are going to draw an arrow like they have going to the right. And we draw that little arrowhead on there because we know that this could go all the way to infinity. Okay? It could be all the way. So you can't just draw a line. Okay? The reason that it's an open dot and you don't shade it in is because we don't want basically what we're trying to get, what you're trying to see is that this open dot does not include 5. In other words, 5 is not a solution here, guys, because 5 is not greater than 5, but anything greater than 5 is. Okay? It's impossible to draw a number line and show a number like this. I mean, that's too hard to do. So we just make that open dot right on 5, and we say anything larger than 5, that would be a solution to this inequality. Okay? And there's your little math note there. The empty circle indicates that the value below the circle is not a solution. So the open dot does not mean it's a solution. It means that's where it starts, but it's anything larger than that. Okay? Let's go on to the next page. Okay. Use substitution. What's this say? Use substitution to determine the solutions of each inequality. Then represent the solution set of each inequality on the number line. So you guys could pick anything. Could I put in 7? No. Could I put in 4? No, because we're talking about values that are greater than 8. So here, 9 would work. 11 would work. 17 will work, and so on. And these are just a few. Okay, I'm just showing you that that there's multiple answers. You can't even count them all. There is infinite answers. Okay, so we're going to draw a number line. Okay, so make sure you draw this. Try to be neat. And all I ask when you're doing a number line is to put 3 numbers on there. 3 numbers. I ask for you to put the number, whatever this is, whatever it's saying it's greater or less than, and put that in the middle. And then just go on one on either side of it. Okay, remember, on a horizontal number line, the numbers going to the right are larger. Okay? So, now we are going to put an open dot. The reason we're using an open dot is because we are talking about values that aren't equal to 8, but greater than 8. Now, where would values be greater than 8? Right there. Okay? All right. Y less than 2. You could plug in some numbers here. Would 12 work? No, because 12 is not less than 2. Again, the inequality symbol is going to eat the larger number, so therefore we need to get a smaller number for y. So 4 would work, 2 would work, and then 0 would work, and then you could even get into negatives if you want to think about it like that. You don't have to, but that would be a negative 5 would work. All numbers smaller than 10 would work. So, for instance, 9, come on pen, 9.999999, would that be a solution here? Yes, it would, because this is 9.9999999 is less than 10. Okay, so what we're going to do, we're going to draw a number line. Okay, we're going to see what the number is that we have, which is 10, and we're just going to put one above it and one below it. That's all you got to do. You don't have to put a million numbers on there. I'm trying to make it easy on you guys. Now just remember, what kind of dot? An open dot. Okay, put your open dot on there, and then just figure out your shading. We're talking about where would the solutions for y be? They would be numbers that are less than 10. Okay, I would like you guys to please pause and try on, just go ahead and do 3 and 4. You don't have to do 5 and 6. Don't worry about those. Just do 3 and 4. Okay, so you could have guessed some numbers here. We're talking about p-values that are greater than 23. So I mean 24 would work, 25, and so on. Okay, we draw a number line. We put 23 in the middle, the number that we're comparing it to. We put one below it, one above it. And remember, we're using an open dot. So where would p-values be greater than 23? Well, they'd be to the right, obviously. Okay. Here we're talking about e-values less than 14. So, I mean, 0 would work, 5 would work, 9 would work. I mean, anything less than 14. Draw your number line. Put 14 on there. Put 13 below it. And then 15. Put your open dot, because we're just doing less than or greater than. Okay, you'll see where that's going to be a closed dot here in a minute. But where would values be? Where would the solutions be of that inequality? Well, just like we listed here, where would 0, 5, and 9 be? They'd be on this side of the dot. So we would shade that way. Okay? All right. Here, Yelena needs at least 7 feet of ribbon for a crafts project. Find the possible lengths of ribbon that would be enough to complete the project. Then represent it on the number line. So we're talking about P being greater than or equal to 7. Now notice it says at least 7 feet. That's how much she needs. So it said to go ahead and use P for your variable. Now realistically you can use anything unless it tells you, which it does tell us to use P there, right? So it doesn't really matter. A variable is a variable. It doesn't make a difference. Sometimes we use the letter that, like, for instance, like in this one, sometimes people would use an R because of ribbon. Sometimes we take the whatever we're measuring in the problem and just use that, the first letter of it. But you don't have to. You could use X. Okay? But she needs at least 7 feet. So we know we're comparing P and 7. Now we have to determine, okay, at least. Does that mean that she could have more than 7 feet and still be okay? Could she have 12 feet and be okay? Yes, she needs at least 7 feet, so 12 feet she'd be fine. Whereas if she had 6 feet, would she have enough? No. So we got to figure out how we would write this inequality to where this length of ribbon is more or equal to the 7 feet, which is right there. Bang. Then the amount she needs is P, right? It says right here, let P represent the length in feet of the ribbon she needs. Let that be what that is, and then she needs at least 7, which means she can have more than 7 or equal to 7 feet. Okay? Now let's go down. You can see these are, she could have 7.4, 8, no, 8.5, all the stuff I just said. Okay? These are all the values of P, and there's so many more than that. Go ahead and go to the next page. Uh-oh. Getting out of crazy here. I think this is the right page, I hope. Okay, now you've got to notice that we got to do a graph. We got to graph it again, and we're still working with the same one, P greater than or equal to 7, because Yelena needed at least 7 feet, which means she could have more than 7, but 7 is fine. Okay, we don't want to do this because it didn't say It didn't say that she needed more than 7. It said she needs at least 7, which would include 7 and more. So that wouldn't be right. Okay, first thing I want you to notice, look what type of dot it was. It's a closed-in dot. Okay, that's very, very, very important. Got to know that, guys. It's a closed dot because we are including that 7 because she could have 7 feet, right? So we use a closed dot whenever you have the or equal to on there. Now, where would p-values be that would be greater than 7? Well, they'd be to the right, as you can see. Let's do a couple of these, and I'll have you do a couple. Okay? Here we're saying Q, whatever it is, has to be greater than or equal to 3. So let's think about the first one. Since it's or equal to, would 3 be a solution? Absolutely. Would 2 be a solution? No. Because it says Q is greater than or equal to 3. So 2 would not work. So that means 3 or more. So that means 4 would work, 5 would work, and so on. Okay? Draw your number line. Same rules apply here. Just whatever you're comparing, you can put that right in the middle. So you can put 3 right there. Put 1 below it, 1 above it. Okay? Now the key here is to make sure that you use a closed dot above 3. Closed dot. Now, where would Q values be greater than 3? They would be to the right, to the greater numbers. Okay? Here we got D is less than or equal to 12. First off, we can use 12. 12 is a solution. 9 is a solution. 10 is a solution. 11 is a solution. 0 is a solution. Is 14 a solution? No. Because it says D values must be less than or equal to 12. So let's make our number line. Again, take 12 and kind of put it right in the middle. 11 and 13 on either side of it. Now we're going to use a closed dot on 12. Now where would D values be? Less than 12? Whereas the solution set, in other words, be to the left. Right? Go ahead and pause and try 9 and 10 real fast. You don't have to worry about the substitution. Just do the graph. Okay? So I'm going to put this on a number line. I know that K values are less than or equal to 25. So that means that 25 would go here, 26 here, 24 here. I know that this is a closed dot because it's or equal to. Now, where would K values be less than or equal to 25? They would be solutions to the left. Okay? We can leave that negative on there. Hope it didn't throw you too much. Maybe it did, but it's pretty easy. We did this. We did number lines with negatives. Okay, we're going to put negative 28 there. The key to remember is, the more negative you go, the smaller the number. So that means negative 29 would be there, and negative 27 would be there. Some of you might have flip-flopped these. Okay, don't do that. Remember, number lines are bigger to the right, smaller to the left. And the more negative you go, the smaller you get. Okay? We're going to use a closed dot on negative 28. Now, where would M's be greater than negative 25? Well, it's obviously going to be this way. Greater numbers are always to the right on your number line. Okay? All right, I like this matching. It's pretty good right here. The first thing I did when I looked at this one is I said, okay, that one is going to be an open dot. This one is going to be a closed dot. Right? Closed dot. This one's going to be an open dot. This one's going to be a closed dot. So I've already kind of made, 11 and 13 have either got to be B or C, or B or C. Number 12 is either going to be A or D. No, sorry, not B or C. B or D, I'm sorry. Sorry about that. Hopefully I didn't confuse you. Okay, and then this is going to be A or C. And you just got to figure out which is which. Okay, so we know that. Okay, so A is showing X values less than 10. Which one of these is showing X values less than 10? Well, it's this one. So this would be letter A. Okay, obviously because you can see it's talking about values less than 10. Okay, whereas this one for letter C, this one's got an open dot on 10, but it's showing values greater than 10. Therefore, this one is letter C. Okay, now let's do this one here. B would be x values less than 10, or less than or equal to 10. So therefore this would be letter B right here. And then this one's showing values greater than 10, which makes it D. Okay? Pretty easy there. I think you guys are probably catching on here. Okay. And then writing your own, pretty easy here. K is less than 12. That's a basic one. Okay. D is greater than 10. Can't imagine us really having any problems with this. If my pen would work, I would get over there. Okay. D is greater than 10. Pretty easy. Okay. By the way, just good rule of thumb here real quick before we go on. Guys, usually we always put the variable on the left of the inequality. It doesn't matter per se. Like, you could write it like this because you can still see it's trying to eat the x. Either way you do it. But the notation that you're going to use in this class and then from now on will usually be variable on the left. Okay, so just keep in your mind to always try to do it that way. This isn't wrong. It's saying the same exact thing. It's saying x is greater than 4. What's saying here 4 is less than x. It's the same thing. But we always put variable on the left. Everybody write that. Variable on the left. And he's happy about it. All right. Let's keep going here. W is greater than or equal to 17. Pretty easy there. Again, these are basic ones. You're just taking it and plugging it in. P is less than or equal to 36. Okay, those are basic. You guys are all fine with those. It's these ones where the problem's going to start. Words like at least, at most, the max, meaning the maximum, the minimum. These are all words that, this is where I think the struggle is going to come a little bit, okay? But hopefully, you know, that we can correct those things, those mistakes now before you start making them, okay? So a sack of potatoes weighs at least 20 pounds. Let X represent the actual weight of the potatoes. Put 20 there. Now we just got to figure out, is it less than or equal to, greater than or equal to, or what? And I always ask this question. Can the sack of potatoes weigh more than 20? Or can it weigh 20? Let's ask that question first. And yes, because it says at least 20. So we know it's going to be an or equal to. Okay? Now we just got to figure out, does this need to be a greater than symbol or a less than? Well, at least means it could weigh 20 or more. So that means that I would have to make this X being greater than or equal to 20. Because these values right here, it can be more than 20. X meaning the sack of potatoes can weigh greater than or equal to 20 pounds. Okay? The maximum number of shirts Amanda can buy is, I can't see that, 9. Okay? So again, I'll use A for Amanda, I guess. Can we just use A for Amanda? Put 9 on here. Now, maximum. Would that mean that she could buy 9? Yes. Right. The maximum number she can buy is 9. She could buy 9. So we're going to put the or equal to on there. Now, maximum number. Could she buy 10? No. The most she can buy is 9. So therefore, A, which A is just the number of shirts she's buying, has got to be less than or equal to the 9 shirts maximum that she can buy. Okay? I'd like you to try these 4 really quickly. Write A. You're going to write an inequality. Just use X as your variable. Go ahead. Okay. Hopefully you've done that, I hope. I mean, some of you probably just wait for me to do it, but I hope you're trying it to get better, but whatever. Okay, first thing I see is it's an open dot, so I know it's either this or this, right? There's no greater than, or there's no equal to on there. So, it's X and 9. Now, is it saying X values smaller or less than 9 or bigger than 9? It's showing less than 9. Okay, this one here, it's showing X values, meaning solutions, that are greater than 14, because it's talking about value solutions that are bigger than 14. Notice it's an open dot. 13, I know right away it's going to have the or equal to. Are we talking about values that are less than 11 or greater than 11? They would be less than or equal to 11. Okay, and then this one here. we're talking about x values being greater than or equal to 7. So I think you're probably getting what we're doing here pretty well. Okay, we're going to skip this for now, and I think that's it. Let me do one of these really quickly. Okay, now if you were to get a fraction one like this, okay, like number 18 for instance, if I were to do this really quickly, it won't take me but a minute, and you wanted to put 6 3/7 there, it's not like you got to do anything crazy. Just make this like 6 and make this 7. So it's about halfway to 7. That's all. Okay, and then recognize if it's going to be a closed or an open dot. This would be a closed dot, and it's wanting to know where values are greater than or equal to that. It'd be that way. Okay, so that's all there is to that. The fractions don't make it any harder. It just, you just kind of got to have a different way of thinking about it, I guess, a little bit. Okay, so that's it. Sorry this was a little longer than I wanted it to be, but it's an important one. So see you guys.